So the doubts related to exercise, particle physics and accelerator, the structure questions. So first is page number 20, question 15. So in question 15A, using the information in the table, use the information, describe how proton changes to neutron, and the composition is given. So what actually happened, the quark composition is also given. So what proton consists of, the quark composition, proton is a baryon which consists of up, and down. So the proton consists of up, and down. What will the net charge? Plus 2 by 3, plus 2 by 3 and minus 1 by 3. So the net charge will be plus 1. And it changes to neutron. When it changes to neutron, it is up, down, down. So it is up, down, down. So up is plus 2 by 3, down is minus 1 by 3, and minus 1 by 3. So the net charge will be 0. So it is up, down, down. So using the information, describe how the proton changes to a neutron. So you just have to mention the quark composition changes. That a proton consists of up, and down, and the neutron is up, down, down. So as a result, what happened? One of the up quark has converted into a down quark. Rest all of them remain same. The only thing what happened, one of the up quark turned into a down quark. As a result, the particle will change or proton turn into neutron. So next out is from page 24. So the diagram shows a track. As you can see, a particle is moving in a magnetic field. And the magnetic field is right angle to the plane of the paper, and its direction is out. So we know the direction of a magnetic field is out of the plane of the paper. AB is a thin sheet of a lead the particle passes through. First, work out the movement of the particle and the sign of a charged particle and explain how you reach your conclusion. So first thing, we have to identify whether a particle is moving from P to Q or it is moving from Q to P. So how to identify this? The idea, you will use the idea that when the particle will move through a lead, it will lose some of its energy. As it will lose some of its energy, so the curvature, the radius of a curvature will also decrease. So this is having a large, when small curvature is like small curved surface, it means it has a higher or greater radius of curvature. When greater, so like change in a direction, it means it has a small radius of a curvature. So at this point at Q, we can say, like for this part Q, the curvature is greater. So if the curvature is greater, it means the radius will be smaller. Like this, if a curve is more, curvature is more, it means the radius, the distance from the center to the curved surface will be smaller. But for P, what happened? You can see the curvature is smaller in the track. So when the curvature is smaller, what happened to the radius? The radius will be greater. And when the particle is moving, the one which is having a higher radius means it will have a greater momentum, or greater momentum is greater kinetic energy. So when the particle move from P, so it means the particle should move from P to Q, because at P the particle is moving faster and at Q the particle is moving slower. How we identify fast or slow is by the radius of curvature of the track. But if the curvature is more, it means it has a smaller radius. So smaller radius means smaller momentum, and smaller momentum leads to lower kinetic energy. Your particle is moving slower. So when the particle moves through this lead, it will lose some of its energy and it will slow down. So here the particle is moving slow and here the particle is moving faster. So we identify that this particle is moving from P to Q. The second thing is, what kind of particle is this? As they mentioned, you will use a Fleming's left-hand rule. Your index finger or the first finger represent the direction of a magnetic field. So index finger or first finger represent the magnetic field that is out. As you mentioned here, magnetic field is out. Your second finger represent the direction of the particle. So the direction of a particle, example, in this case, if we take for P or Q, so direction of particle in this manner. So your index finger should point out. Your second finger represent direction of the particle. Where your thumb is pointing. So your thumb is pointing downward. It means like in this direction. So when your thumb is pointing in this direction, it means if there was a positive particle, then it should go in this manner. But because it's an opposite particle, a negative particle is there, so it is moving in opposite direction. So the second point you will mention, you're like using a Fleming's left-hand rule. We will identify according to the magnetic field, and if the particle was positive particle, then it should move. If there was a positive particle, then what should happen? It should move downward, but it's not moving downward, it is moving upward. So this is not a positive particle, this is a negative particle. Is it clear, this one? Next is page number 27. And the doubt in this one, 27, 19B, 19B1. In another experiment which is involving a head-on collision between the two protons. So two protons collide head-on, and the following interaction was observed. The mass of a proton is given, mass of a pion is given as well, mass of a kaon is given, mass of a lambda is also given. Calculate the minimum kinetic energy for each proton in mega electron volt for this interaction to occur. So like the total mass and plus the kinetic energy of the two protons will give us mass of these particles. And because they're asking minimum kinetic energy, so minimum kinetic energy means like we just produce this particle. We assume that these particles will not move. So what is the equation here? Like the kinetic energy, the total energy, or a kinetic energy of the two protons plus the mass of the two protons producing the mass of these particles. Like we assume they are not moving. So if we write the equation, because how much kinetic energy is required for this? So you can also do like as an equation. So kinetic energy plus the mass of protons equal to mass of the product, all the particle in the product. So if I need the kinetic energy, the mass of the protons will move other side. So I need the mass of a product minus mass of the, like the mass of the product minus the mass of the protons. The two protons will get the kinetic energy. And when the mass is given in mega electron volt per c square, so mass in mega electron volt per c square is same as energy in mega electron, or mass in giga electron volt per c square is same as energy in giga electron volt. Like you don't have to convert the unit in that case. So mass of a product, what is the total mass of a product? When you check, so one proton, like here in a product, we have one proton is there, so 938 plus mass of a pion is same, pi positive and negative is same, which is 140. And how many of them are produced? 7 and 7, so makes 14. So we multiply this by 14 plus mass of a kaon is 494 plus the mass of a lambda particle is 1115. This will give us the total mass of the product minus the mass of the protons, because twice the mass of proton as 2 protons are there. So 2 multiplied by mass of a proton, that is 938. Here, why we did not convert the mass into kilogram? Because the simple way is, if we have the mass in mega electron volt per c square, that will be same as energy in mega electron volt. So we just have to subtract these numbers. When we subtract these numbers, we'll get the total kinetic energy. We'll get the total kinetic energy of the 2 protons, which is 2631. 2631, and that is mega electron volt per c square, or it is same as mega electron volt, because the unit of energy is not mega electron volt per c square. You can simply write mega electron volt, but this is the kinetic energy of 2 proton. We need for 1. So to get the kinetic energy of the 1, the total kinetic energy divided by 2. So 2631 divided by 2, we get the kinetic energy of each proton, which is 1315.5. So 1315.5 mega electron volt is the kinetic energy of one proton. So for these type of questions, if the mass is given in mega electron volt or giga electron volt per c square, the answer of energy will also be in either mega electron volt or giga electron volt. Is it clear, this one? Page 27, this was 19B. Then the next question, page number 36, question 25. Okay. The photograph shows a part in a European organization for nuclear research in Switzerland. So a teacher on a tour says the group of to a group of students, in fact, nearly all the matter in the structure is made up of 2 first generation particles in combinations called a baryon and 1 type of lepton. However, the matter is mostly empty space. Explain this statement. So we have to explain this statement that when you check the different types of particle like baryon, in this case, we have quarks are also there. We have, these are the quarks are there, up, down, charm, strange, top, bottom. And we have lepton families also there. Like this is a first generation particles, means like these are the particles which were discovered in the first stage. That's a first generation particle. Then at the last, we discover about top and bottom and neutrinos and tau. These are the third generation particle, means they are discovered at the last. So as we know, according to the statement of the teacher, it's written, in fact, nearly all the matter is made up of first 2 generation particles. So what matter consists of? Every matter consists of atoms. And what atom consists of? Atom consists of a nucleus, like in the central part of an atom is nucleus. So inside the nucleus, there are protons and neutrons, and electrons are revolving around. And what is the composition of the proton? What proton consists of? The proton consists of up, up, and down. And what neutron consists of? Neutron consists of up, down, down. This is a composition of proton and so as it mentioned, all the like nearly all the matter is made up of first two generation quarks. So that's right. Like because you'll mention all the matter consists of atom. Inside an atom, there are proton, neutron in the nucleus, and electrons are moving around. Protons consist of up, up, and down. So this is the first generation particle. And up, down, neutron consists of up, down, down. That is also a first generation particle. And its combination called a baryon. Proton and neutron are also known as a baryon. So this till here is correct. And one type of a lepton. So as electrons are moving, electron is a lepton. So electron is moving around the nucleus in the region which we call shell or an orbit. So the points you will mention and major why, as I mentioned, the last part of the statement that the matter is mostly empty space. So major portion of an atom is empty, as we know from the Rutherford experiment. Most part of an atom is empty. That's why the alpha particle scattering experiment, most of the particles were able to pass through the gold foil. So the points which you will mention, first thing you'll mention, every matter consists of atom. Atom consists of proton, neutron, and electron. Proton and neutrons are inside the nucleus, and electrons are outside the nucleus. Protons are consisting of three quarks, combination of quark, which is up, up, and down, and neutron is up, down, down, and which shows that they're first generation particles, like up and down are the first generation quarks. And because they are consist of three quarks, so we call them as a baryon. And electrons are moving around the nucleus, so they are leptons, and that also a first generation lepton. Is it clear discussion? The next is page number 42, question 29. This is about the cyclotron. Proton of a mass m and a charge q is there. It is non-relativistic spread means that it is not moving with the speed of a light, because if it move with the speed of a light, the mass will also change. So show that the time for a proton in 1 of the d is given by a formula T is equals to pi m divided by bq. So short derivation, it's a short derivation. First, you can start, it's a 2-mark derivation. So you can start from a concept that the centripetal force is equals to magnetic force. You can start from there, but because the 2-mark derivation, so you can also start from, because when we say centripetal force is mv square over r and magnetic force is qvb. So this v will cancel with a square. So we can say mv over r is equals to qb. So mv over r is equals to qb. That's the first thing we compare, because the magnetic field is causing a circular motion. Or you can also say mv over qb is equals to r. Now we need for one, because when object move in a circular path, so what is the circumference? Circumference is 2 pi r, like moving in a circular path when it completes one circle. But in the question, the time for a proton in 1D means a semicircle or half of the circle. So what will the distance for half of a circle? The distance of half of circle will be pi r. So we have the formula: speed is equals to distance over time. So time is distance divided by speed. And what is the distance? The distance will be equals to pi r. The distance will be by pi r because it's half like d. That's why pi r, and divided by speed v. If I substitute the value of r from here, because we calculated, so if I substitute the value of r from here, from this equation, so t is equals to pi v, and what is the value of r? The value of r is mv over qb. So this v will cancel with v, and what we are left with, so it will be pi m by qb, where q is a charge. I use a small q. You can use a capital Q here, because in the question they mentioned the charge is capital Q in the question. So we'll use a capital Q. But it's the same idea, that the time taken to complete in half of the d, that will be pi r by pi m by qb. Is it clear, this derivation? Next is page number 44. On this page, the doubt is 30C. For a particle with a relativistic velocity m square raised to power m square and c raised to power 4 is negligible compared to e square. So equation simplify to E is equals to PC. So that this is a correct and the simplification is justified for an electron with the energy of 45 giga electron volt. Like if we have electron with a energy of 45 giga electron volt, we can ignore this factor. As I mentioned here, m square and c raised to power 4. The particle with a relativistic velocity means like it is moving close to speed of light. M square c raised to power 4 is negligible compared to e square. So we just have to work out the value of m square c raised to power 4 with e square, and we have to compare like how many times it is smaller or bigger, and it will show that it will be smaller. So if you work out the value for because like we can work out the value for mc square, and then we will square that again, it will become mc square square. So it will become m square and c raised to power 4. So first we can work out the value for mc square, and just the final answer of mc square we will just square again to get the m square c raised to power 4. So what is m? M is a mass here for which electron is there. So we'll take a mass of electron. It's a constant value. You can check the constants. It's 9.11 exponent minus 31. And relativistic speed like means like it is moving closer to speed of light. So it is 10 to the power 8 square. When we simplify, it will give us 8.2 into 10 to the power minus 14 joules. Then what will the value for m c square whole square means m square c raised to power 4. So it is simply 8.2 into 10 to the power minus 14 square. So which will be equals to 6.7 into 10 to the power minus 27. And that will be, the unit will be joule square, because it's like E is equals to mc square, and then this will be joule square. Now we want to compare this with the energy. Like we have to say this factor is very small compared to when the electron is having the energy of 65 giga electron volt. So this giga electron volt will convert into joules. So the electron energy is 45 giga electron volt. So giga means 10 power 9. So it will means 45 into 10 power 9 electron volt. And for electron volt, if you want to convert into joules, so 45 into 10 power 9 multiplied by 1.6 into 10 power minus 19. So we multiply this. And because we want to show that E square, like this value is negligible compared to E square. So if you want E square, we just simply have to square this number. 45 into 10 power 9 multiplied by 1.6 into 10 power minus 19 and then square this number. So when you square this number, it will be 5.2 into 10 power minus 17 joules. So when you compare these two, like when you compare these two, how many times, like you take a simplest ratio. To show that the correct, this is correct and the simplification is justified for electron with an energy of 45 giga electron volt. So when you work out, E square is there. And when we work out E is equals to mc square, this was our answer. 6.7 into 10 power minus 27. So when we compare these two, like this is joule square, when we compare these two values, we divide it by the smallest value, like 5.2 into 10 power 17 is a value for E square. So m square c raised to power 4 and E square. So this was 6.7 into 10 power minus 27. And this is 5.2 into 10 power minus 17. So we divide by the smallest value, we divide both of them by 6.7 into 10 power minus 27. So how many times we'll get this factor? It will be about like 7.8 into 10 power 9 times. So which is a very big difference between the two. Is it clear, this question? This was page number 44. Then page 49, 33A. A3. A peak voltage of AC is 250 kilovolts. Calculate the increase in the kinetic energy in joules to move from A to D. So we know the voltage and we want to find how much kinetic energy has increased as it moved from A to D. So every section, like when it is moving within the cylindrical tube, it does not change the kinetic energy, it will be constant. But when it will move from one plate to another, the kinetic energy will increase. How much the kinetic, look, so which section the kinetic energy increase? Like in this part, the kinetic energy increase, this part, the kinetic energy increase, and this part, the kinetic energy increase. And so how many times the kinetic energy increase? The kinetic energy increase 3 times. And every time how much it has a kinetic energy. So we have the formula, like how much energy it gain. Voltage is work done or energy per unit charge. So voltage into charge is the energy. So we find how much energy it gained here, how much energy it gained here, and how much energy. So the total energy which it gained, that will be 3E. So the kinetic energy in tube D will be 3 times the kinetic energy or energy it gained in between the tubes. And voltage is given in the question. which was 240 kilo. So this 250 kilovolts, so 250 into 10 to the power 3. And this is the electron, which is 1.6 into 10 to the power minus 19. So, and this is the kinetic energy gain in each section, but it should be multiplied by 3 because it is passing through 3 sections. So it will be multiplied by 3. So the total gain in kinetic energy will be 1.2 into 10 to the power minus 13 joules. So this is the total gain in kinetic energy for this particle. Next is page 53, question 36. A photon of a visible light is incident on a stationary hydrogen atom. A photon return in opposite direction with the same wavelength when the measured to too significant. Hydrogen atom move with a velocity v. Use the principle of conservation of momentum and the equation lambda is equals to h over p. Calculate the speed of hydrogen after the interaction with photon. So this is refers to a Compton effect, like when a particle or a photon interact with a particle. So we can use a conservation of momentum, like momentum before collision. According to law of conservation of momentum, momentum before collision should be equals to momentum after collision. So lambda is h over p. So p is equals to h over lambda. Planck's constant divided by wavelength. So before interaction, what is the momentum, like the total momentum before collision? It will be h over lambda plus 0. And after, because it has changed the directions, it will be minus h over lambda. And this momentum will be mv. So if we write the equation, the conservation of momentum, the equation for that, like momentum before equals to momentum after. So h over lambda plus 0, that is the momentum before, the sum of momentum of two particles or two objects before collision will be equals to sum of momentum after collision. So we can simply say lambda h over lambda equals plus 0 is equals to minus y minus minus h over lambda. Sorry, this one I have opposite. It should be minus h over lambda. Why minus h over lambda? Because it has changed the direction. So when there is a change in direction, we took negative sign as momentum is a vector quantity and m into v. V is the velocity and m is the mass of this hydrogen atom. Hydrogen atom consists of one proton and one electron. So we'll just substitute, like we'll simplify. This will go other side. I'll use this space. So h over lambda plus h over lambda is equals to mv. So lambda will be in LCM, least common factor. So 2h over lambda is equals to mv, or 2h over m lambda is equals to v, where 2 is because the direction has changed. That's why the factor 2 is there. So we'll just substitute all the values here. So 2 multiplied by Planck's constant, which is 6.63 into 10 to the power minus 34, divided by m. What will the mass? We will take, this is a stationary hydrogen atom is there and a photon opposite. So mass of hydrogen atom is given. So mass of hydrogen atom is given, which is 1.6. So we write 1.6 into 10 to the power minus 27. And wavelength, the lambda is there, which is 640 nanometer. So 640, you have to convert into meter, 10 to the power minus 9 will be there. And this will give us the speed at which this hydrogen atom will move, which is about 1.24 meter per second. Is it clear, this one? And for part B, the data given in direction is inconsistent with another conservation law. Explain this inconsistency and describe the effect of recording a wavelength more significant value. Like what actually happened, it will appear that conservation energy, when we check about conservation of energy, it won't be accurate. Like how we can work out the energy of a photon, we have the formula E is equals to hc over lambda. So if wavelength is not changing, means energy should not change. But like before the interaction, it is E is equals to hc over lambda and the wavelength is not changing, hc over lambda. But there is a particle moving. So it means before the energy is less and after the collision energy is more. Like before the collision energy is 100, after the collision is 106 example. So that is a contradictory to conservation of energy. So when we record the wavelength to more significant value, we can identify how much the wavelength has changed, and using that change, we can the data will be consistent with the conservation of energy. So with these values, it shows that the energy is not conserved because before collision energy is less, after collision energy is more because the particle is also moving, the hydrogen atom is also moving, and the photon is also moving with the same speed but in opposite direction. So we have to record wavelength to a greater number of significant figure to have a more precise result and apply the conservation of energy on this interaction as well.